Hi, my name is Lemieux, and I'm from VectorBlox. I'm here to demonstrate our flagship product, the VectorBlox MXP matrix processor. The processor is a high-speed processor meant for vision and other types of data parallel tasks. So we have our processor implemented as FPGA IP on an FPGA board here. And as a demonstration system, we have video coming in and out between a camera and a screen. And we're manipulating the video in real time using software only by programming our processor. Our processor uses a host processor such as ARM, Microblaze, or Nios. In this case, we're using an ARM Cortex-A9 running at 666 megahertz. And as an example, we're going to do face detection on the 1080p video. On the screen, we can see that face detection involves looking across the entire frame, pixel by pixel, for a face. And it has to handle small faces when you're very far away, and large faces as you get close up. Handling a wide range of faces is more computationally intensive because you have to take the original image and keep on scaling it down and keep on searching for faces that are larger and larger as you scale the image down. So it's more compute intensive. With our coprocessor, we can achieve a near real-time frame rate of 25 frames per second, or about 35 milliseconds. If I switch to the regular ARM A9 in an unaccelerated mode, this is taking 3 seconds per frame, or 0.3 frames per second. When I switch back to the accelerated mode, then we can see that it actually works as real-time video, and the overall speed up is about 80 times faster. This acceleration is happening by having parallel ALUs. We have a gang of 16 ALUs running at 100 megahertz. And these ALUs are running in a lockstep fashion. They can operate on 32-bit data, or we can divide them into 16-bit ALUs and have twice as many of them, or 8-bit ALUs and have 4 times as many of them operating in parallel. So if we're operating on 8-bit data, we actually have 64 parallel ALUs running at 100 megahertz, or 6.4 GigaOps per second. That's one of the reasons why we're able to get such a high performance on analyzing the video. Another reason we get high performance is those GigaOps are real data computation ops, manipulating the data itself. We don't need extra ALU cycles in order to calculate the address of the pixel, or in order to calculate the loop counters or loop bounds, or do branching or things like that. So we get rid of unnecessary instructions, which provides a speed up. This is a natural benefit of vector processing. Another reason we get good speed up is we can prefetch the next data and hide the memory latency entirely while we're computing on a current tile of the overall image. And so we do this double buffering throughout, and we never pay the penalty of the memory not being ready. So the other thing is, because it is a processor, we can change the algorithm on the fly and add other algorithms and even combine algorithms together. If you were to use this development system in a hardware mode and combine hardware algorithms, it can be very difficult to connect and compose algorithms. In software, it's very easy. So here we're showing edge detection on one half of the screen, and at the same time, I'm still doing face detection on the entire frame. Or I can do edge detection on the entire frame if I want and not do any face detection at all. So I hope that gives you an idea of the capabilities of our vector processor. We can do real-time 1080p video manipulation. So there's plenty of time to do things like vision tasks and video analytics, or just quality improvement on image and video processing. Thank you.